Hello, my dear energetic students, joshful students, ready for the NSEP exam. The exam is just around the corner, and this is the time when you should be solving as many PYQs as possible. So, today we are going to start with question paper of 2022. We'll pick up four questions. We believe in quality over quantity. My name is Bhavdeep Sethi. I've been converting a lot of physics haters into physics lovers, and I always say, physics ko ratta maroge to physics bura मान जाएगी. And I also encourage you to go out in nature, explore nature. You will see physics all around you. Physics is the best, sorry, the nature is the best physics teacher out there. Now, what you should not be expecting here is obviously the spoon feeding. If you're expecting I'll display a question, give you all the steps to solve, that's not going to happen. I'm going to go in depth into the concept, but then I'll give you some pointers and expect that you are going to solve yourself. That's the best way to learn. Dates are out, so 24th November is your exam, and I'm hoping that you've already filled out the registration form. So, looking at the very first question here, a particle moves along a straight line. Its displacement s varies with time t according to the law s squared is equal to at squared plus 2bt plus c. A, B, C are constants. The acceleration of this particle varies as. So, you have to find what you have to find is what is acceleration as a function of s. And that's what you have to find. Now, one thing what I don't like about this question, honestly, is using the letter A. Honestly, I don't want to confuse the students. I mean, I honor the question paper here, but that A confuses many students. So please do remember this A does not stand for acceleration. It is a constant. They should have taken alpha, beta, gamma or some PQR, but that's okay. Let's live with it. So we have to find acceleration as a function of S. If this is S, I know acceleration is going to be the second derivative of that. So let's go that route, obviously. So we start by saying, okay, I know s square is this. So let's find the derivative both sides so that we will get velocity. So when you do the derivative, you use the chain rule, you get 2s ds by dt. Right, that's I'm using the chain rule over there. Is equal to, now derivative of this will be 2at, and the derivative of this is 2b. And C doesn't give you anything because C is a constant, the derivative of the rate of change of constant, or constant says I will not change. So now these two, they will cross out. So to save the space, I'm just going to wipe those out. So this is what you have. So that's your beginning, and you say, okay, I have s and ds by dt, but I need the acceleration. So you do derivative again. You do the derivative here. You use the product rule. So derivative of this times this as it is, then this as it is, and derivative of that. Remember the product rule there. So you'll say, oh, derivative of this, which is ds by dt, and then you leave this alone as it is. So ds by dt, it is as it is. So what I have done is I have treated this as a constant, and this is the derivative of this. Then you say plus. Now it's your turn to be finding derivative. So leave this as it is. Leave this as it is, and then this is the second derivative of. That's what we need. So d2s by dt square. I mean, that's how many people call it. But honestly, this is the second derivative of position with respect to time. And this is acceleration. This is what I have to find. So everything has to be isolated on that side. But wait, we are not done. So derivative of b will be 0. Derivative of this is a. Wow, I get it. So this is my answer. But then, okay, how does it vary with s? So I have to take everything on the other side. But remember, there should not be any s in the numerator or denominator. There should be only one because we ultimately have to find. You know, so some things have to be constant either in denominator or numerator. We'll see that. Now this is ds by dt square, right? ds by apple time apple, apple square. 5 times 5, 5 square. ds by dt times ds by dt, dy by dt square. So this is ds by dt square. Taking on the other side, what you get is s times the second derivative. And this is what I have to find. This has to be isolated. So this is equal to a minus ds by, oh, this is t. I'm really sorry for that typing error or writing error. So ds by dt square, but ds by dt is, remember this. So I have to find everything in terms of a, b, c, and s. Those are given. So ds by dt is a t plus b divided by s, the square of that. So a plus AT plus B, sorry, AT plus B, so AT plus B whole square over S square, right? That's ds by dt is AT plus B divided by S. So I've done square of that. Now this has to be brought there. So what I can do is I can bring this here and then say divided by S. I can take this out. So I have acceleration something as a function of S, but I'm still not done. Because see, remember what will happen is this will be carried over here. So it's not like it's a numerator or denominator. You should not be, see, the answer is obviously this one, but you don't make a conclusion as of now. So what if this S remains in numerator? So we still have to solve it. So when I solve it, this goes up. So what I get is this is equal to, so this is equal to AS squared minus AT plus B, AT plus B whole squared over S cubed. Right? That's what you get. So don't make conclusion as of now because there is S squared over there. But what you realize is this S square is AT squared plus 2BT plus C. As soon as you plug in here, a lot of things will cancel out here. All you will get is a constant in the numerator and S cube in the denominator. So you will get this answer, but you have to try it out. So please, everybody, try it out. As I said, I'm not going to do spoon feeding. You will see for yourself. You plug in S square as this value, a lot of things will cancel out here. Okay, going to the next question, very beautiful question. I love this question because the reason for that is many students solve this in 15, 20 steps. You Google for this solution, you will find 15, 20 steps. This question is so beautiful, it can be done in 5 or 6 steps. That's the beauty of this. So a ball A of mass m1 moving with a velocity of v experiences an elastic collision, no loss of energy. Loss of energy is never there, no loss of kinetic energy. With another stationary ball B of mass m2, and they fly symmetrically along this way. So all they're saying is the angle being theta, what is the ratio of m1 by m2? I mean, a lot of students start with the equations of kinetic energy and momentum and all that. There's nothing you have to do here if you realize that if they are going symmetrical, then they will have the same momentum. Think about it, we'll see that. But if they're going symmetrical, irrespective of their masses or their velocities, their momentum has to be equal because there was no momentum along the y-axis. Whatever is the contribution of this has to be there because it is same angle. So let's make the diagram before we speak so much. So there was a body of mass m1. It was moving with velocity v. Honestly, I don't like to use velocity there because momentum has more meaning because we are saying momentum will be. So let's say it has a momentum of p, let's say. That's more meaningful. And we know p is, wherever needed, m1 times v. I don't need that. So there was another mass m2 because I'm telling you many questions that you will solve. Momentum will be the easy approach. It has zero momentum here. Now they collide, and what happens next is very interesting that this m1 flies this way with, let's say, some momentum p1. So let's say call that p1. I need some space there, so I'll actually make this closer to this. So let's say this is, I still am debating on, okay, m1 moving with some momentum p1 here. And let's call it p1 and p2 for now. We don't know they will be equal. Mathematically, I have to show first that they're equal. And this is p2. Now they're telling us that this angle is theta and this is also theta. So think they're saying they're telling us. So they fly symmetrically related to the initial direction of motion of the ball at an angle of theta. This is theta, this is theta. Wow. So in the along the y-axis, momentum was zero. It has to be zero. So can I say P1? So let's write down. So can I say P1 sine theta? P1 sine theta should be P2 sine theta, isn't it? Because to cancel out this momentum has to be equal and opposite to this. So okay, sine theta, sine theta. So momentum, it's not P1 and P2. They are both same. They have to be same. So then I'll say, okay, no, wait. So I'll call them as something like P naught, P naught. whatever you want to call. I mean, something, some same number out there. Good. So we conserve the momentum along y-axis. We got the conclusion that both the momenta are same. Masses are different, velocities are different. Good to know. But then product of those will be same. Okay. Talking about x-axis, if I conserve the momentum there was momentum of p. There was momentum p. That should be equal to how much? That should be this component here, which is p naught cos theta, and this is also p naught cos theta. Okay, so then that should be 2 p naught cos theta. And you will see how you can solve these questions in 4 or 5 steps. You don't have to go very messed up kind of noodle method there. We got this. Okay. But this is leading us to nowhere because the question says what is the ratio of mass 1 and mass 2? I have momentum, and this is not helping me as of now because I don't know velocities. If I plug in velocities here, that's another variable. Okay, hold on. It says elastic collision. Elastic collision, no loss of kinetic energy. So kinetic energy of this, and it's a scalar quantity, so no direction needed. Kinetic energy of this is equal to kinetic energy of this plus kinetic energy of this. So what is the kinetic energy of this in terms of whatever we have? Half mv square? No, we are talking about momentum. So p square by 2m1, isn't it? So p square by 2m1, that's the kinetic energy originally. That should be this kinetic energy, which is p naught divided by 2m1. Okay, p naught square by 2m1. That's the kinetic energy of this. So momenta are equal. Kinetic energy may not be equal, right? And they are not equal. For this, it's p naught by 2m2. So p naught square by 2m2. Okay, we have got closer somewhere at least. We have masses in place, but then these momentum or momenta, they're bothering me. But then I realize, think about it. First of all, this 2 crosses out. So I'm going to remove that 2 to make it simpler. Okay. So I need ratio of masses in terms of theta. But nowhere do I have theta. I've instead have these but see, this p is 2p naught cos theta. If I plug this in here, you realize all those p naughts will cancel out, and what I have is only cos theta. And we need answers in terms of something like cos theta. So you plug this in here. So what you get is 4. You get 4 p naught square cos square theta by m1 is equal to p naught square by m1 plus p naught square by m2. Very, very close to our solution now. So you realize, first of all these p naught square cross out to make my equation so much of easy now. If you bring this part here so that you have clubbed them together, you get 4, okay, p naught. So that thing is gone. So let me bring this 4 closer here. So what you get is 4 cos square theta minus 1 over m1 is 1 by m2. So m1 goes there. So m1 by m2 comes out to be, so let me write it here, m1 by m2. I get 4 cos square theta minus 1. That's my answer. I'm done. Yes. But wait, none of them are the answers match because it's cos 2 theta. Not a big deal. So what is cos 2 theta? Cos 2 theta will be 2 cos square theta minus 1. So what is 2 cos square theta? You borrow 2 from here. So you get 2 cos square theta is cos 2 theta minus 1. So 2 cos 2 theta. Right, so 2 cos square theta is left. So that is cos 2 theta, my bad, cos 2 theta minus 1. Minus 1 or plus 1 actually, that goes in there, so makes it plus 1, minus 1. That's your answer. So you'll see 2 cos 2 theta plus 2 minus 1. So this is your answer. Try it out yourself. Think about it, how we solved it, like very logically, conservation of momentum, conservation of kinetic energy. Okay. This one is easy. I don't know why they have given in NSEP, but remember NSEP exam is all mix of easy, medium, difficult. I'll call this question very easy. It has been part of a lot of JEE exam, NEET exams earlier. A solid cylinder of mass m is rolling without slipping. So there is no slipping over there. No slipping means the angular acceleration will be the linear acceleration divided by the radius, right? So there is no slipping. That's good. Under the action of a horizontal force F such that the line of action of F passes through C. So this is not contributing to any rotation. That's the easy part there. Had this been a thread, it would have added more steps there. Choose the correct alternatives. They're saying acceleration of the center of cylinder is F by m. Frictional force on the cylinder acts forward. So first one is not right, obviously. See, the whole point is if this were a box, you apply a force F, it will accelerate with F by m. But think about it, some of that thingy is going into rotation also. So you can clearly see first one is out. Frictional force on cylinder acts forward. Are you kidding me? I mean, if it were acting forward, it would have rotated this way. But by logic, right, observation there, if you're pulling this, it's going to rotate this way. So friction is responsible for rotation. So even part B is wrong. C and D, I don't know. I mean, I still don't know. I mean, I have to find which one is right, but I'm telling you how you can at least eliminate. So I know this one can be eliminated, this one can be eliminated, but we'll see mathematically also. But let's see. So to start with, I at least know the friction force has to be backwards because had this not been backwards, you're trying to move this way. So there is a relative motion this way. Friction says, I'm going to stop you from moving. And that friction force is actually rotating this. Okay, let's talk about rotation then. This is not contributing to any torque about this center. This is contributing to torque. So this F times the radius will be the torque. And we know torque is equal to I times alpha, right? So we know how this would be rotating. So torque is F times R. So F times R is moment of inertia. Now this is a solid cylinder, so like a solid disk. So half mr square times alpha. Right, so now I can cross this out, this r and this r cross out. So I'm left with r alpha. R alpha is the acceleration. So I know the friction force is equal to mass times acceleration by 2. That's one thing I know for now. Okay, good. But I still do not know what's happening here. I don't know the magnitude of friction force. Is it F by 3 or none of these? I still don't know. So let's say we'll talk about the translatory motion. Translatory motion F, I can say F minus F is equal to mass times acceleration. Now I have something here. So this is ma by 2. I can plug that in here. So I get F minus m by 2 is ma. So I get F is equal to 3 by 2 ma, isn't it? Because that ma by 2 goes in there. Okay, so from there I can see the first option was wrong because acceleration is coming out to be 2 by 3 of f by m, and then that has to be less than f by m because some of it is going to rotate. So acceleration is f by m. No, it's 2/3 of f by m. Okay, good. So first was wrong. So how much is magnitude of friction force? Friction force is ma by 2. Okay, then I know A, so let's plug it in. So m by 2 times acceleration. Acceleration is 2 by 3 F by m. Okay, so I cross out this m, I cross out this m, I cross out 2 F by 3. So this is my answer. See how easy it is. Okay. A motor pump is used to deliver water at a certain rate R from a given pipe to obtain thrice as much water from the same pipe in the same time. The power of the motor has to be increased too. So it's pumping water at certain rate. I want to make it 3 times. What would be the new power? So how do we even start? What is power? Power is energy per unit of time. But here, water is being pumped through a pipe. Pipe has certain area of cross section. And think about this way. Let's go logical here. So let's say this is a pipe. This is a pipe. Now, if the area were A and the velocity is V, so whatever molecule was here, that molecule would have traveled V distance. So in 1 unit of time, this much of water would have been moved. How much water would have been moved? V stands for velocity, not the volume here. So how much volume, first of all, of water is moved? This much of volume of water is moved, where this is velocity. Area times velocity is the amount of water that has been pumped. That's the volume. Now, if I were to multiply that by density, this much of mass of water has been pumped. So if the water is flowing at a velocity of V through cross-sectional area A, these many kilograms is pumped in 1 second. So this is basically your dm by dt, as in how much mass is being pumped every second. This is the mass of water, right? To obtain thrice as much water, what should be the power? So what is power, first of all? So first of all, I have to make this 3 times. Do we all agree on that? We have to make this 3 times because this is the amount of water being pumped every second. So we are saying, okay, I want to make this 3 times. So what should be the new power? Is it going to be 3 times? No. Because do you think power is proportional to this? I don't know. Let's figure that out. Because see, when you're pumping this, you're pumping with more velocity also. So think about power in terms of velocities and masses. So what is power? Power is F times velocity, right? F times velocity. That's the power. What is F? F is the rate of change, momentum. But think about this way. So if the velocity is to be incorporated in this formula, can I not say force velocity dm by dt? So you plug that in there. So what you have is v times dm by dt times velocity. So what we are saying is if I want to make this 3 times, good, I can make this 3 times, but when I'm making this 3 times, this is also becoming 3 times. So this is becoming 3 times, this is becoming 3 times. Overall power is becoming 27 times. Think that way. Because when you want to pump 3 times water, this becomes thrice, but even velocity becomes thrice. So 3 times 3 is 27 times will be your power. And this is a very beautiful question because if you know the basics of this, you could have solved this question in less than 30 seconds. Otherwise, you will be struggling with all those fancy equations, the noodle method. Okay. So if this was logical, I encourage you to like, share, and subscribe to this, and also let your friends know about these PYQ series. I'll be back here every Tuesday, Thursday, Saturday, 4 p.m. I'll be back with PYQ series. That is my promise. Every Tuesday, Thursday, Saturday. Okay. So we have also started a paid course if you're interested. It's called Full Physics Mastery 2025. This is for students who are targeting NSEP 2025 and beyond, or JEE NEET exam 2026 and beyond. If your target is a long-term conceptual study, this course is for you. And also this is for students who want to fall in love for physics forever. It is divided into 5 modules. So first 3 modules are 11 syllabus, last 2 is 12 syllabus. The links are below there. First module is already over. So you don't pay for this. We'll give you the free recording of this. You start from here. You pay for these 4 modules of 10,000 rupees minus the discounts, obviously. So these are the modules. Any prerequisites? No academical prerequisite, but definitely you need a lot of Josh to enter these classes. And you can use this coupon BS Pro 1, or you can click on the link below. It will directly take you to those. And a lot of students have been benefiting, obviously. And I also encourage you to spread out the word. And I promise every Tuesday, Thursday, Saturday, I'll be back with PYQs here. So thank you so much. Keep up the high Josh, students. Bye bye.